Hey everyone, and welcome back, but not to Ideanthro. Okay, if you're new here or if you've seen me on a video before, we've got a bit of context to fill in, about 5 years worth. So, in a moment, we're going to go taking a look at a stormwater treatment system, have a little investigation. It's actually one that I've filmed a few times before, kind of 5, 6, 7 years ago, sort of thing. And I've decided to revisit it. But the question is, why was it so long ago? And in fact, why has it been 5 years since I made a video? Here's the thing. I used to make all sorts of videos about water sensitive urban design, and I absolutely loved it. But I had another passion, which is human movement. And I decided to take a massive big detour out of the water space, out of the water sensitive urban design world, and open a gym. And that gym's just about 1 kilometer up the road from here. And so I devoted 5 years of my time to it, and it's going really quite nicely. But I'm coming back into the water world part-time because I miss it. I miss the challenge, I miss solving problems around this sort of stuff, and I miss making these videos, if we're really honest. So I'm coming back into the water space a little bit, and I'm gonna restart making videos, I think. I'm certainly giving it a crack today. But I'm not doing it under the Ideanthro banner. I'm going to be doing a little bit of work initially with Healthy Land and Water, and then we'll see what happens down the track after that. But I want to make the videos so they're just me at the moment. I might name this at some point, but for now, it's just me doing it. So, why'd I pick this site? Well, it's close to home. I live a little bit that way. It's close to the gym. It's a little bit that way. It means I drive past it every day for like 5 years. And I think I've stopped in once and taken a look. And I'm curious, so I was like, look, let's come out here, let's look at a site and how it's progressed over the years and see what we find out. It'll be a little bit like the old episodes where I used to investigate a site and see what we could deduce. One quick point here is I've also moved this series across onto my own YouTube channel. The reason for this is, when I moved out of the water world and I went to the gym, I took the name Ideanthro with me to the gym, and it's now probably more strongly attached to the gym, and I'm not making the mistake of confusing those two things again. So the older Ideanthro videos still exist. You can find them on jackmullally.com. But from here in, that name is the gym, Ideanthro Movement. Okay, let's pick up this camera and go have a look. So what we have here, we're talking about this system that you can see down this way, like so. And as a brief reminder here, there was always this channel that came down here. And in fact, before this system was built, this channel just continued down like so, down to the creek at the bottom, out towards Oxley Creek. And Brisbane City Council built what they called at the time one of their creek filtration systems, which is, they were like low-tech stormwater treatment systems. So it was an attempted look, how do we get something in that's not too costly to try and treat some stormwater? And the design was, they built a little weir, which you can kind of still see the remains of where those rocks are there, across this channel, to divert water into a little diversion, which is much harder to see along here. And they built a level spreader. So where all the grass is kind of running, as I pan across through the center of shot here, where all the grass is through the center of that shot, after the bank, but before you hit, say, that first Melaleuca, there is a level spreader running across. So the intent is the water would fill up the little channel down in there, and then spread out evenly across that spreader and flow evenly through the system. It would head down through, like away from camera here. And at the bottom, it would be diverted back right and back into the channel further down. Critically, there's no outlet pit, there's no under drains. There's also no level spreader at the other end, no like level control for the water in here. It can just flow out. So water can't pond in this system unless it's backwatering from the creek way down the bottom. And so initially it was really densely vegetated, so it was planted out with Melaleucas and then a mix of different understory vegetation. There were definitely Lomandras, because I can still see the things, but there was a mix of other stuff, and I've forgotten what these days. But we can see it's changed a lot now. And the biggest change you'll see initially is there's a whole heap of sediment buildup. And I think there's definitely a lesson here. This system, because it's on this channel that's like, it's draining quite a big catchment upstream, where there, let's be honest, forever is going to be sediment coming down, because there's going to be renovations, there's been house building work over the past well, decade or more, but there's bits of house building going on, but there'll be renovations, there'll be people building new houses on single lots, but there was some new development up there as well. There's always going to be some kind of sediment load coming down here. And so one of the first lessons is this 4-bay sort of area clearly hasn't been cleaned out anytime recently, and it's filled up to the point that this diversion is almost certainly not working much. It is possible that some water, there's a little low point around here, that some water might be hitting the weir and diverting out through here into the system. That's actually on the wrong side of the level spreader. So some water might be getting in, but I doubt it's much right now. So there's definitely a problem there. I've not necessarily, like in typical bioretention setups, where there's just like a pipe into the system and there's a 4-bay at the front, I haven't always been the most convinced that a specific 4-bay for cleaning out all the time is required. But in this setup with this like diversion here, where it's level controlled by this weir as to whether the water gets in rather than a pipe just jetting in, this definitely needs to be getting cleaned out from time to time. The other thing that strikes me here, well, several things. Firstly, it's clearly had a lot of sediment build up. So it's clearly done some of what it was made to do over time, because you can see there is tons of sediment building up around these melaleucas here. I know this channel used to be deeper, it's filled up, and then there's an even higher patch around the melaleucas of sediment. So it's clearly been catching stuff, which is, that's a good thing. And it's possible that in really high flows, right, that water might be getting in here simply because it just finds a spot to kind of spread out as it hits that little weir area. But yeah, we come down here. You can see a little channel down the left. This has always been a bit of a problem with this system. I don't remember the channelization, and I'll point in here. It's along there. I don't remember it being this far up the system, but certainly way back in the day, when the level spreader was still working, if you walked down here, down the system, eventually somewhere down the left here, you would see that the water was all preferentially heading to this side of the system. In fact, there might still be a bit, maybe there's a little bit of evidence of that in there, although interestingly, it's not as severe as I remember, not yet. Anyway, we'll keep exploring, we'll see. See, this is how we suss this stuff out on the go. Now, curiously, there's probably some weed control going on in here, because there's young weeds popping up around the place, but also not. Although maybe it could be some. It could just be the trees doing it. Yeah, look, you can see there's a little bit of a preferential flow around here. I'd have to be here in rain to know exactly for sure what's going on there. Although it's curious because it doesn't seem as bad as I remember. So potentially that's kind of self-corrected, which is curious. But the reason I raise this is that originally I was quite concerned about this, because the whole concept of a level spreader is you need water moving quite evenly through the system rather than kind of rushing down one end, because if it's just rushing down one simple path, it's not getting as much treatment as it would. Because say in a bioretention system where most of the treatment is happening from water filtering vertically down through the filter media, then you know what, if it initially runs into the system a bit channeled, it doesn't matter so much because it's got to filter through at some point. Obviously we don't want it eroding, but it's got to filter through at some point in time. But in a system like this, where it's just going to run down through the system, down one edge and then out the bottom, because there's no level control at the end, there's no way to make it pond back up in the system or anything, then that could be, that's a real problem because it's short-circuiting the system. But curiously, maybe that's self-correcting a little. Maybe it's all this leaf litter has finally stabilized, because that's new. Like looking at all that leaf litter there, which is a combination of melaleucas and these casuarinas here. The interesting story with those, they weren't on the original plan, and the team, this is what I've been told anyway, the team from BCC who built the system decided it would be a really good idea to put some around the edge, and I think they made a cracking decision with that personally. I always have thought that was a good choice, but when you start to see some of the leaf litter around here potentially helping to suppress weeds, yeah, really good. And so the last thing that I think is really worth observing here is what's happened with the vegetation. Firstly, the melaleucas have got up really established. Once again, melaleucas love being in ephemeral stormwater treatment systems like bioretention systems, or like this creek filtration, which is bioretention without underdrains sort of thing. Melaleucas love it. Lamandras doing really well underneath the melaleucas. What a surprise. That's such a tried and tested planting mix these days that's not surprising. But I think there's a really important thing for anyone trying to do level spreader designs to take away from this. And that's the fact that we look around here, and there, even in this bit, which is pretty well vegetated, there are gaps between the plants here. There are gaps, there are gaps, there are gaps. In a normal bioretention system, where water is going to pond in the system when it's raining, bit high flows are going to overflow over the outlet pit, but they're going to pond up in the system and then drain down through the filter media. This is more than enough vegetation cover. If we went digging in here, we'll find plant roots all throughout the filter media, and that's going to be doing good stuff for treatment, right? But in a level spreader, where we are relying on water coming kind of horizontally through a system, and yes, some is sinking in and getting treated, but we're also relying on it moving horizontally through the plants and stuff getting filtered out that way, then we really need like 100% cover for that, because there is lots of opportunity in this system for water to work its way around the plants. Now, I'm not saying this isn't doing anything. I'm sure it's doing stuff, but is it doing as much as it might be? Don't know. And the challenge here is that almost any system that you go to that uses this tried and true bioretention planting mix, almost any system that you go to like this is not going to have absolute complete understory cover. This is how this develops. You look at this in nature. You have melaleucas, you have lamandras, you have gaps in between, and the leaf litter and the shade from the system controls the weeds pretty well in there. I think it's a big question you have to ask yourself if you're designing something akin to a creek filtration system, a level spreader, that sort of thing, is how am I going to get 100% coverage? And I don't want to trash the idea by any means, because I actually really like so much about this system, but it's quite the conundrum. How do I get that much cover? Because if you take the trees away, then weeds are way more of a problem in the system. And so you can be like, okay, look, the reason we don't have plants wall to wall here, partly is probably because some of them have been sprayed out or whippersnipped out by maintenance. There was evidence of that 6 years ago. But part of it is this is just kind of where this planting mix heads towards. So you got to ask this question, like, okay, the trees are absolutely amazing. This is one of the reasons this planting mix is really resilient. It's because the trees shade out the weeds. But when you have the trees, you also sometimes don't have a complete coverage underneath. So we go, how do we get the complete coverage underneath in the understory? Well, do we take the trees out? Okay, now we've got way more possibility of weeds coming into the system. So even if you do get really good coverage of the understory, then suddenly you're dealing with weeds, constantly having a fight there. It's a big question. I don't have an answer to that. I still really, by default, like this approach in this type of system, just because we know this planting mix is so resilient here. But it's questions worth asking for sure. And potentially one really simple solution to this, because remember that the underlying problem that I identified here is that because in a normal bioretention system, we would have some extended detention depth where water could fill up in the system, be captured and slowly filter out over time. And the fundamental problem here is that this system, because it's got no underdrains, there were presumably some concerns about how quickly it would drain. We're actually on the subsoil here, beneath the filter media is actually quite clayey because it's oxley. Presumably there were some concerns that if they put any extended detention depth on this, that the water would pond and then not be able to drain away, and we'd eventually drown out all the plants. So there's no outlet control on it. It's just a channel out the other end back into the channel down the side. One potential solution to this would have been to put just a very small amount of extended detention depth, like 50 or 100 mils, control the outlet with a level spreader, and then that would mean that water would actually just back up a little bit in this system at times. A little bit more water would get captured, a little bit more would filter in. And then because we were emphasizing more filtering in and water was staying in the system a little bit longer, even if just at surface level, it wouldn't matter as much that the vegetation cover has some gaps in it. So that's actually, if we go for what's Jack's takeaway from this system, I really would love to have seen some outlet control on it, even if it gave very little extended detention depth. And that would have also potentially helped to deal with the channelization issue that I talked about before, although that doesn't seem to be as much as a problem as it was 5 years ago. Okie dokie. Well, that was fun. That was a blast from the past for me. I hope you enjoyed, and I'm going to continue doing these. I don't know on what frequency, but yeah, it was good fun. Until next time, have a good one.